Chapter 1 will serve as an introduction and an overview to computers, programs, and the Java programming language. We will start by defining what a computer is, discuss its various components, and define a computer program. We will introduce the relationship between Java and the World Wide Web, and by the end of the chapter you will have written your very first Java program with output to the console. This course is about programming, computer programming. Programming means to develop software or programs, which are instructions that tell a computer what to do. Software or programs are written to solve a problem, and software programs are written by programmers in a programming language that a computer can understand. Before we begin writing programs, we need to establish an understanding of what a computer is and its various components. It is important to understand that a computer consists of both hardware components and software. Let's first take a look at the hardware components of a computer. The CPU, or central processing unit, is the brain of the computer. The CPU has two components, the control unit and the arithmetic logic unit. The CPU retrieves instructions from memory and executes them, or carries them out. It is the job of the control unit to coordinate or control all of the other hardware components. The ALU, or arithmetic logic unit, performs all of the arithmetic and logical operations. For example, addition, multiplication, subtraction, division, and logical comparison operations. The core is the part of the processor that performs the reading and execution of instructions. Originally, CPUs only had a single core. Today, however, the CPU contains multiple cores, resulting in much greater processing power. Memory is the hardware component that is used to store data and programs. Memory is the computer's workspace. A program and its data must first be moved into memory before it can be executed by the CPU. But how is information stored in memory? Well, a computer is really just a series of switches that corresponds to one of two states, on or off. All data stored on a computer is just a sequence of switches. We represent on with the value 1 and off with the value 0. 1 and 0 are digits of the binary number system, so we call each value, a 0 or a 1, a bit. A computer groups these bits into a series of 8 bits, which we refer to as a byte. If a number or a value does not fit into a single byte, then the computer uses multiple bytes. Fortunately, as a programmer, we do not need to concern ourselves with the coding and encoding. That's the job of the computer. The computer uses a unique encoding scheme, such as ASCII, to determine how characters and numbers are translated and represented in these zeros and ones. So a kilobyte is approximately 1,000 bytes. And remember, a byte is just 8 bits. In memory, every byte has a unique address that the computer uses to store and retrieve the data. Memory is often called RAM, or random access memory, because the information stored in memory can be accessed in any order, that is to say, in random order, not just sequential order. Generally speaking, more RAM means faster processing time. RAM, or random access memory, is volatile, which means when the computer loses power, on purpose or accidentally, all of the information in memory is lost. Therefore, programs and data must be stored on non-volatile storage devices, such as magnetic disk drives, optical disks, universal serial buses or USB drives, or cloud storage. Each of these offer a permanent storage solution for programs and data. It is important to note, however, that RAM operates much faster than permanent storage devices. Input devices allow the user to communicate with the computer. The two most common input devices are the mouse and the keyboard, although there are others. Output devices allow the computer to communicate with the user. The most common output devices are monitors and printers. The quality of a monitor's display is determined by the screen resolution and the dot pitch. Pixels, or picture elements, are tiny dots that form an image on the screen. The screen resolution specifies how many pixels are placed horizontally and vertically. Thus, the higher the resolution, the sharper and clearer the image. Dot pitch refers to the space in millimeters between each pixel. Therefore, the smaller the dot pitch, the sharper the image. Long gone are the days when our computer worked in isolation. Today, we will most often connect our computer to a network through a communication device. Communication devices allow computers to communicate, that is, to send data back and forth. There are several types of communication devices available to us. A regular modem using a phone line, a DSL or digital subscriber line, which also uses a phone line but has a much faster speed than a regular modem, a cable modem, which is usually faster than a DSL, and a network interface card, or NIC, which connects computers together in a local area network, such as a home, a school, or even an office. Now that we have an understanding of what computer hardware is and what it does, we will look at software, which is what makes the hardware components work. Remember, there are two components to a computer, hardware and software. Both are vital, and neither will work without the other. Without software, the hardware that we just discussed is nothing more than an expensive paperweight. When we talk about software, we're talking about computer programs, instructions that give the computer functionality. And we will use the terms software and programs interchangeable to mean instructions that tell the computer to do something. Since computers do not understand human languages per se, we must write out programs in a programming language that a computer will understand. So now let's take a look at the various types of programming languages. Remember that computers are electronic devices based on binary, 0 and 1. They only understand primitive instructions written as zeros and ones, and we call this machine language. It is the lowest level of programming languages. All programs must be converted to machine language, these zeros and ones, before they can be executed on a computer. Thankfully, we do not have to program this way. Assembly language, another low-level programming language, was developed to make programming easier. Assembly language is easier to write and easier to understand than machine language, but remember the computer only understands machine language, zeros and ones. So that means the assembly language has to be run through an assembler which converts the code written in assembly to machine language. Again, thankfully there are even higher level languages that we can use that are more like our native language. The focus of our class will be coding or programming in those higher level languages. In this class, we will be focusing on programming in a high-level language, specifically Java. Java and other high-level languages are English-like and far easier to learn than lower-level languages such as assembly language or machine language. There are many different high-level languages that are used today. Here's just a sample of some of those languages. The program that we write in a high-level language is called a source program or source code. Remember, the computer only understands machine language, zeros and ones. And so we have to use a tool called an interpreter or a compiler to do the job of translating our source program into machine language, or those zeros and ones that the computer can understand. An interpreter translates our source code into machine language and executes or runs it immediately. So the interpreter reads one statement from our source code, translates that statement into the equivalent machine language statements, and then executes those machine language statements. It then reads in the next statement in our source code and repeats the process until all statements in the source code file have been executed. A compiler achieves a similar result, but instead of translating and executing a single line of source code before proceeding to the next line, a compiler translates the entire source code file into a file of machine language and then executes the entire machine language file. Once again, thankfully, we have tools that do this translation for us so we don't have to. The operating system is the most important piece of software on a computer. The operating system, or OS, manages and controls all of the resources and activities of the computer. No other software can be installed or run without an operating system. Some of the most popular operating systems are Microsoft Windows, Mac OS, and Linux. The major tasks of the operating system are controlling and monitoring system activities, allocating and assigning system resources, and scheduling operations.